5.6 is the derivatives of inverse trig functions. Inverse trig functions, if we deal with, say, here's an example, y equals the arc sine of x. This is the inverse of the sine of x, only if the sine of y equals x. So notice here that when we have a sine function, the input is an angular measurement in radians here in calculus, and the output is some value on the unit circle. With an inverse trig function, the input is some value on the unit circle, and then the output is an angular measurement in radians. All right, so when we have trig functions, we have to restrict the domains in order to make sure that the inverses are also functions, otherwise they won't be functions. If we think about what the inverse sine of -1/2 is, we have to imagine what is the what angular measurement gives me a sine of -1/2. And so we have to think about our unit circle. The sine of -π/6 is what gives us -1/2. So the inverse sine of -1/2 is -π/6. And a similar example here for arc cosine. All right, let's take a look at an example here. We're trying to find the tangent of y, given that y equals the arc secant of √5/2. And the way to do this is to use a right triangle. So what we're trying to find really is the tangent of the arc secant of √5/2. All right, and so in order to do that, if I think about the angle y, I can build a right triangle knowing that the arc secant, the inverse secant, is √5/2. So that means that √5 is my hypotenuse and 2 is my adjacent side. All right. I figure that out because I know that secant is the inverse of, it's 1/cosine. Right? And cosine would be adjacent over hypotenuse. So the arc secant is hypotenuse over adjacent. Now I can fill in the remaining side. So I know I can use the Pythagorean theorem. I know this is a right triangle here. So the hypotenuse squared minus this leg squared is 1. So the square root of 1 is 1. So now the tangent of this angle is just opposite over adjacent. So we get tangent of y equals 1/2.